Hi, today I will be showing a video about multithreading in Java. In general, there are two usages for multithreading. One is under the scenario that we have multiple resources, we can run multiple threads at the same time. And second is for shared resources, we will run multiple threads as soon as the resources are available. For example, given 3 pairs of clothes, we would want to wash, dry, and fold each of them. The following are the 3 ways we can do in programming. One is single thread. In single thread, we will finish washing, drying, and folding of 1 pair at a time, while in multi-threading, we can wash, dry, and fold all 3 pairs at the same time if we have multiple machines of each. Or if we have only one machine of each, we can wash, dry, and fold the clothes as soon as the machine is available. We will go on to see how we can do it in Java. So first of all, we will have to create washer, dryer, and folder class. For washer, I'll put the thread to sleep for 2 seconds. And for dryer, I put the thread to sleep for 5 seconds. And for folder, I will put the thread to sleep for 2 seconds as well. So these are the 3 machines that we'll be using for our class. So in Java, for multi-threading, there are 3 ways. One is we create a class and we extend the class to thread. Thread is the class that tells the Java virtual machine to run in a different process. So we can extend the class and then we override the run function, and whatever inside the run function will be called when the thread is started. But as you can see, Java can only extend one class at a time. So this is a disadvantage when you have a larger application that you are creating in Java and you have class that you will need to extend, then this will not be able to fulfill your wish. So another way of doing multi-threading is to implement the runnable. So Java provide another interface called runnable, which also provide the function run. And all you need to do is you implement the runnable interface, and that you can override the run and put this class into a thread and it will run for you. So this is very similar to extending the thread. Only different is it does not limit your logic to extend another parent class. That means you can extend any of other parent class for your application. At the same time, you can still do it in multi-threading. And lastly is to do the multi-thread as an anonymous runnable. That means you do not need to keep track of what class is running, and all you care is as long as it's running the different thread. So this way you can do for anonymous, there are 2 different ways that you can do. As for Java 8, they introduce the lambda function where this code here is same as the one below. So we will be using the one above and we will comment out the one below. They are the same, only different is you do not need to declare the runnable and the function while you can do it as a lambda functions. So and this is a class where there is a main function. So I will go through the code and show what I'm doing in this main. First of all, I created the 3 instances of the machines, the washer, the dryer, and the folder. And then I will record the time and also created 3 pairs of clothes, cloth 1, cloth 2, and cloth 3. And for each cloth, I will do washing, drying, and folding. And then I will print out what is the runtime of doing it in a loop, which means this part is running as a single thread because I did not declare any other thread for running the process. That's why it may take quite a while. But after that, I will create a worker thread, which is the thread that I created earlier that extend the thread class, and a runnable that implement the runnable interface, and an anonymous runnable, where I'm just gonna let it run and I do not record the class. So similar to the single thread, I record the time and then I make those 3 threads to run, and then I will wait for them to finish and print out the runtime. So let's try to run it and see how it goes. So now it's starting. As you can see in the loop, for single thread, it has to finish washing and then drying and folding for the cloth 1. Then it move on to the cloth 2 for washing, drying, and then folding. And then lastly will be cloth 3 for all 3 of them. And you will see that it took 27 seconds. But for multi-threading, we will be doing it for washing all 3 at the same time, and drying all 3 at the same time, and folding all 3 at the same time, and it took only 9 seconds. Like I said earlier that we have 2 ways of multi-thread. This way means we have multiple machines, like we have multiple washer to wash all 3 at the same time, we have multiple dryer to dry all 3 at the same time, and we have multiple fold machine to fold all 3 at the same time. But sometimes we may want to share resources. So in Java, in order to do sharing resources, we need to use the keyword synchronize. So I will show you in a second. Go to the washer machine. For synchronizing, we can use this keyword synchronize. And for this keyword, you have 2 ways of implementing synchronizing. So you can synchronize the whole function by putting the synchronize keywords in front of the function declaration. Another way of doing it is, I'm going to do it in a different class. Let's say for dryer, I can do it by doing it as synchronize and then put in the instance, and whatever inside here will be running as a synchronized code. So what happened for synchronize is that when a function or block of code that's declared as synchronized, whatever thread that comes after will have to wait for the current thread to finish this block of code, then the next thread can move in and do it. So imagine you have a washer and you want to wash your clothes, but then because this is a synchronized function, that means if the first bag of clothes is under washing, the second bag has to wait until the first bag finish. So as the dryer, if I put this code, this block of code into here, you will see that for drying, the same thing, it will have to wait for the cloth to finish all drying, the first cloth to finish drying, then the next cloth can move in, and so on. And then I will do the same thing for the fold machine as well. So this time, as we should expect that it will run longer than the multi-thread before, because earlier we have 3 machines for all of them, but this time we are sharing the machines. So last time we run for 9 seconds. Let's see how long we will run for this time. For multi-thread this time, it will have to finish washing the cloth 1, then they put the cloth 3 into wash while drying the cloth 1. And then when the cloth 3 is done washing, they will start washing cloth 2. And when the cloth 1 done drying, then they put in cloth 2 to dry and then fold it. As you can see, it took 19 seconds. And you may have noticed that the order doesn't seem to be right. That is because for multi-threading, you want to put the process to run as soon as the available resources is there. That's why the order may not come out the way that you want it to be. In that case, you may not be able to keep track on which line of code will come in first. And that's it for showing the multi-threading. Thank you for watching.